Hi and welcome to this video on exponents and understanding the laws of exponents. If we have x to the power m, x is the base and m is the power or the exponent. When we talk about x to the power 2 or x squared, this is a product, so it's x multiplied by x. If we have the sum of two bases, x plus x, this is simply 2x. So we mustn't get this confused with x times x, which is a product, is x squared. X plus x, which is a sum, is 2x. Now, when we're combining exponents, if we have x to the m, x to the n, x to the m, this then becomes 2x to the m plus x to the n power. If we have a coefficient in front of the base squared and that squared, we just simply add the two and that becomes 4 lots of x squared. That's if the bases are the same. X to the power 0 is simply 1, so that's anything to the power 0 is simply 1, and x to the power 1 is x. x3 divided by x3, this then becomes 3 minus 3 so 3 minus 3 is 0, so that becomes x to the 0, and x to the 0 is 1. Now for multiplication, what we do is we add the powers together, so this becomes x to the m plus multiplied by x to the n is x to the m plus n. So for example, x cubed multiplied by x squared, the product of these two, where the bases are the same, we add the powers, so that becomes x, and 3 plus 2 is 5. If we have, as an aside, we have 3x squared multiplied by 2x cubed. What we do here is we multiply the coefficients, so 3 times 2 is 6. The bases must be the same, and then we can add the bases, so 3 plus 2 is 5. So 3x squared multiplied by 2x cubed is 6x to the power 5. Similarly, if we have some monomials and we have 2x squared y multiplied by 3x to the power 4 and y to the power 2. Again, we multiply the coefficients, so that's 2 times 3 is 6. X squared multiplied by x to the power 4, we add the powers, so that's x to the 6, and then the y, we add the powers, so 2 plus 1 is 3. With division, we have x to the m divided by x to the n. So what we do here is we subtract m minus n. So for example, in this, x to the power 5 divided by x to the power 3, we have x 5 minus 3 equals x to the power 2. In this one, we have a power raised to a power. So this is x to a power m, and all that is raised to a power n. In this case, what we do is we have x m multiplied by n. So for x to the power 3, all raised to the power 2, this becomes x to the power 6. When we have a product raised to a power, we multiply each individual component by that power. So here this would become 4 squared, a squared, b squared. 4 squared is 16, and then we'll a squared, b squared. If we have a quotient raised to a power, then we multiply each individual component again. So this would equal 3 squared and a squared all over b squared. This in turn, 3 squared is 9, a squared remains over b squared. If we have, as an aside, x to the power 5 over x to the power 2 raised to the power 3, this then becomes x to the power 15 over x to the power 6, and then we do our quotient rule, and that is 15 minus 6 if the bases are the same, so that becomes x, and 15 minus 6 is 9. A negative exponent is a reciprocal. So a to the minus 2, first of all we write a to the power 2, a squared, and a reciprocal, the negative, just means it's 1 over a squared. Similarly, if we go in the opposite direction, 1 over a to the minus 2 is a squared. We can think of this one as 1 over a to the minus 2 equals 1 over a squared, and that equals a squared. Let's go over fractional exponents, which are quite important, and a lot of people misunderstand fractional exponents. You have to learn these. If it's a half, that's the square root. If the fractional exponent is a third, that's the cube root. Similarly, if it was 1 over 4, 8 to the quarter, that would be the fourth root. So let's just write this down. So 16 to the power half, that's the square root of 16, which is plus or minus 4. Similarly, 25 to the power half is the square root of 25, which is plus or minus 5. 8 to the power third, we simply put the root sign 3, so that's the cube root, and then the 8 goes underneath, and the cube root for 8 is plus or minus 2. If we have something like 125 to the 2/3, simply do the third first, so this would then become, like we did before, the root symbol, the 1, 2, 5, the 3, and then all in brackets, and then the 2 goes there, power 2. So this becomes the cube root of 125 squared. 81 to the fractional power 3/4. Again, we draw our root symbol. The 81 goes under there. The 4 goes outside, so that's the 4th root of 81, brackets, and then the 3 goes there. 125 to the minus 2/3. So again, let's just take it as we did before. Draw a root symbol. 125, 3 outside, and then the minus 2. Okay, here I've summarized the laws of exponents, where a is a constant. When we're multiplying, we add the powers. When we're multiplying something in brackets, something to a power, and then we're raising that to a power, we multiply the powers, so that's mn, a to the power mn. When we're dividing something with the same base to different exponents, we subtract m minus n. A, or anything to the power 0, is 1. A to the power 1 is just itself, a. When we have something to a negative power, it's the reciprocal. So a to the negative 1 exponent is 1 over a. So a to any negative m is 1 over a to the m. The minus just stands for the reciprocal, which is 1 over. A to a fractional power, a to the half, is the square root, so we could write a 2 there, so that's the square root of a. A to any reciprocal 1 over m is simply the root, and then the m root of that constant or coefficient. A to the n over m simply becomes the reciprocal 1 over m to that power. Okay, we're going to go over some solving exponential equations. Two techniques. The first one is where we make the powers equivalent to each other, and then the bases are also equivalent. So for example, 4x plus 2. So we can see that we can make the 4 into a 2. So 2 to the power 2 is 4. That'll be to the power x equals 2. Then we use our laws of exponents, so that becomes 2 when we get rid of the brackets, to the 2x equals 2 to the power 1. Because these two bases are the same, we can cancel those out. 2x equals 1, and then x equals a half. Another similar one, so we're going to make the bases the same and then the powers are equivalent to each other, so we can make the powers equivalent and ignore the bases because they're the same. So 27 is 3 to the power 3. And this is to the power 4x. 9 is 3 to the power 2. And this is to the power x minus 1. So this becomes 3. Laws of exponents, 3, getting rid of the brackets, 3 times 4x is 12x. This equals 3. 2x minus 1 becomes 2x minus 2. So here we have 12x equals 2x minus 2, because we can get rid of the bases and just the powers are equivalent to each other. Now when we solve this, take the 2 to the other side, so that becomes 10x equals minus 2, and x is minus 2 over 10 because minus 1/5. 2 to the power 3 minus 2x equals 8. Let's make the bases the same. So 2 to the 3 minus 2x, and then 8 we can write as 2 to the power 3. Once the bases are the same, the powers are equivalent to each other, so we can ignore the bases and write 3 minus 2x equals 3. 2x then equals 0, and x equals 0. In this one, again let's make the bases the same. So 6 to the minus 1, 3x minus 2. 36 is nothing but 6 squared, and we've got x plus 1 as the power. Now let's get rid of the brackets by multiplying out. So we get 6 minus 3x plus 2 equals 6. 2x plus 2. Now we've got the bases the same, so we can ignore those, and the powers are equivalent to each other. So minus 3x plus 2 equals 2x plus 2. So x is again 0. Try to make the bases the same, so we can see that this then becomes 5 over 2 x. The power x is 4 is 2 squared, and 25 is 5 squared. 5 over 2x. We want to bring the 2 to the bottom, so that becomes 2 to the minus 2. Take the 5 to the top, that becomes 5 to the minus 2. Now we see that we can make these equivalent, so 5 over 2 power 2 equals 5 over 2 to the minus 2. Sorry, that should be x. Therefore x equals minus 2. In this next one, ex e to the power 2 equals e to the 4 e to the x plus 1. Now let's have a look at this. Combine these two, so we add the powers, so that's ex plus 2 equals, now we're going to have e to the 4, and because we're dividing, we minus x plus 1. This then becomes e to the 4 minus x minus 1, which is e to the 3 minus x. So then e to the x plus 2 equals e to the 3 minus x. Because we've got e on both sides, the powers are equivalent, so that's x plus 2 equals 3 minus x, 2x equals 1, and x equals a half. The second method of solving exponential equations is to take the logarithm on both sides. We can do this because if we take the logarithm on both sides, the ratio remains the same, and then we can just solve using this log law, where the exponent comes down and it becomes x log a. So let's have a look at a simple example. So 3x equals 7. So we're going to take logs on both sides, or it's easier to take natural logs. So natural log 3x equals natural log of 7. Now what we do is we bring the x down using this log law, so x ln natural log 3 equals natural log of 7, and then we take the natural log of 3 to the other side to solve, and we get x equals the natural log of 7 over natural log of 3, and that's our answer. Let's have a look at this second example. So we're going to take logs on both sides, so this becomes natural log of 2x plus 3 equals natural log of 5 to the 2x. Now we bring the power down, so that's, we bring the power down and the exponent then becomes the coefficient, so that's x plus 3 natural log of 2. So we brought this down here, equals 2x natural log of 5. Now when we get rid of the brackets here, this becomes x natural log of 2 plus 3 natural log of 2 equals 2x natural log 5. Now what we can do is here minus x log 2 from both sides to get rid of this x. So minus x log 2 on this side. So this gets rid of that, so we're left with 3 natural log 2 equals 2x natural log 5 minus x natural log of 2. So let's factor out an x over here, so this becomes 3 natural log 2 equals x, and we're going to factor out an x, so this becomes 2 natural log 5 minus natural log 2. We divide now to get x by itself by this. Divide both sides by that. So this then becomes 3 natural log 2. 3 natural log 2 is simply, let's do it on this side, 3 natural log of 2 is, that should be natural log of 8, and this becomes natural log of 8. Let's take the natural log on both sides of this, so this is natural log of e to the x squared equals natural log of 100. Now because we've got the natural log of e and e together, these cancel each other out and become 1. So this becomes x squared is the natural log of 100, and x is the square root of the natural log of 100. We can add the powers because it's a multiplication. So e to the 3x minus 7 add minus 2x, that simply becomes e to the x, and the minus 7 remains, and then on this side we have 4e. Now if we want to get rid of the e on this side, we can divide through by e. This leaves us with e to the x minus 8 equals 4. Now we can take natural logs, so natural log of e x minus 8 equals natural log of 4. This is simply 1, So x minus 8 equals natural log of 4. So x equals natural log of 4 plus 8.